of orthogonal vectors. It got cut off. So it says by vector addition, we can write V as a sum of vectors V, and there's a subscript right there, the projection of V onto B, and W2. So right there is the formula. I'm going to actually just write it right over here. See where it says orthogonal vectors? That's where it gets cut off. Okay. So we're going to just jump right into this lovely thing. Okay, so it says find the vector projection of V onto W. Then write V as a sum of two orthogonal vectors, one of which is the projection of V onto W. Okay, so let's start simple. Step number one, we're going to do the projection. Okay, so we're going to do the projection vector first, and then basically what we're going to do is we're going to find W2 is what it is, and not saying W2 like your taxes, but W2. All right, so you take 2 times 3. I think we can just go right into this. 6. You're going to take 6 times 3, which is 18. And I'm going to do this here because I'm going to run out of room. Sorry, I shouldn't have put a V. I should have put W. Oops, W. So you're going to do 3 squared, which is 9, plus 9, because that's 3 squared, and that gets you square root of 18. And you don't need to simplify it because you're going to square it anyway, and that 18 is just going to go there. Do not cancel out these 18s. Holy crap, don't do it. Don't do it, don't do it, don't do it. Okay? So this is what you end up with. You're going to do the 6 and 18 together, and you get 24 over 18. 24 and 18 simplify to 4/3. You're going to multiply that in. The 3's would cancel, and it's actually just going to be 4/4. So the projected vector is just 4/4. Oops, made that a parenthesis. All right, step number 2 is you're going to actually use this formula. Okay, we already know what vector V is. So let me just rewrite this. Okay, so when you find the projection vector, that's the W1, and that's what we talked about on that first page, kind of, but it's also written in your notes. So we're just going to plug and chug this. So V is 2, 6. We have W sub 1, or subscript of, W sub 1. That's so weird to say. 4, 4. And then we're trying to find W2. Okay, so it's just kind of like what you used to do with algebra. We're just going to subtract this over. It's just really weird. And so I'm going to write this over here. And you just collect like terms. So it'd be 2 minus 4, so negative 2. And 6 minus 4, which is 2. So we get that, but we need to write it in form of the sum. So we have to rewrite it from basically this. So we just plug that W2 right into there. So the answer I want is really V equals 4, 4 plus negative 2, 2. So it's really, 2, 2. It's really, really easy. So that's your answer, okay? So number 4 is similar. We just have to understand that there's a J here and there's no I. So because there's no J there, you really can think of this as or I there, like this. Okay, and we're going to do all the same steps. But in this situation, I want to see how far you can go without me. So I'd like for you to try to get at least to the projection on your own, if not the whole thing. If you get it all figured out, just fast forward the video to the answer. And if you need help, then follow the instructions. So go ahead and pause the video now. Okay, now that you restarted the video, and I always do that, without a doubt. Okay. We're finding the projection vector, and we're going to keep in mind that's the same thing as finding that, okay? So V doesn't have an I, so we have to have more think of it like this just to be safe. You're going to take 0 times 8, which is 0, and then you're going to take 2 times negative 6, which is like subtracting 12, or plus negative, which I don't really want to see. And then if you want to find the magnitude, you would take 8 squared, which is 64, and negative 6 squared, which is 36. If you add that together, you get the square root of 100. Okay, and the square root of 100 is 10, but there's really no point of simplifying because you're going to square this whole thing anyway. So when you take this and square it, you get 100. If you were to take that and square it, you get 100. So either way, it's 100. And they're going to write 8, negative 6. So you get negative 12 on top, 100 on the bottom. Sorry, brain fart. And then you have 8, negative 6. You can simplify this, but negative 12 divided by 100, I'm cheating, and I shouldn't. That's the same then as negative 3 over 25. So if you were to go ahead and put that through, you would get negative 24 over 25 and 18 over 25. And the signs flip because there's that negative right there. So just keep that in mind because that 0 kind of messed with you. So that's your projection vector. And then the second step is you would do this whole v equals w sub 1 and w sub 2. So we know what v equals. V equals 0, 2. And w sub 1 is that negative 24 25ths and 18 25ths. And we need to find W2. So you would subtract this over. So I'm not showing a lot of work. You're going to subtract this whole thing over here. So you're going to do 0 minus this. So when you subtract a negative, you get a positive. So you get 24 over 25. And then you would take this 2 minus 18 over 25. And if you do 2 minus 18 over 25 in your calculator, if you do it by hand, which I'd prefer, you get 32 over 25. Okay, so v equals, and we have to rewrite this, a lot of fractions, negative 24 over 25, 18 over 25, plus 24 over 25, 32 over 25. And that would be your final answer. Okay, I'm going to end it here for the second video and move on to this force applications. Like I said, we're kind of going to chunk this up as much as possible. So in the left-hand corner, you should see a link for the next video. All right, see ya.